Hello everyone. Managing traffic effectively becomes increasingly crucial as your web application scales up and attracts more users. That's why we're going to see how we can connect our NestJS API to an AWS load balancer and setting up auto-scaling groups such that EC2 instances can be created as needed based off a template. We'll briefly discuss the essential role of load balancers and compare the differences between an application load balancer and a network load balancer, so we have the context to be able to utilize the AWS ecosystem and deploy our NestJS project to scale. Let's take a quick look at our NestJS application. So here we see we just got a basic hello world application, and in the app controller we've just added this get request to the endpoint/host. And that will just call the app service method, which I've created here, get private IP or hostname. And what that will do is they'll just get the IP address of the EC2 instance that we're on. And I've done this because we're going to create two or multiple EC2 instances. And I want to check that our load balancer is doing its job and offloading the work to different EC2 instances. So I want to start off by talking about load balancers, and then we'll talk about the differences between ALBs, NLBs, and ASGs. So feel free to skip ahead. So let's just discuss why load balancers are beneficial. Load balancers are beneficial because they can distribute the load across multiple servers, enhancing server robustness and availability. EC2 instances can be managed by an auto-scaling group, so we can scale the servers as much as needed. Load balancers, they provide backup in case of server failures, ensuring uninterrupted application operation. SSL termination is offloaded from EC2 instances to the load balancer, mitigating the need for this to be performed on each instance. Client session stickiness ensures that a unique client's request is consistently routed to the same server. Elastic load balancing, or ELB, is a managed load balancer where AWS handles maintenance, monitors instance health, and includes built-in recovery mechanisms, which simplifies the complexities associated with setting up a load balancer. There are two load balancers I'd like to discuss and compare: the application load balancer, or the ALB, and the network load balancer, or the NLB. So the ALB, it operates at layer 7 of the OSI model, allowing it to route traffic to multiple applications across machines or within the same machine using HTTP. It facilitates URL-based routing, directing different endpoints to specific servers based on the URL path. On the other hand, NLB operates at layer 4 of the OSI model, and directs traffic based on IP address and ports without inspecting application-level content. NLB excels in high throughput, low latency, and robust support for TCP/UDP protocols. ALBs are well suited for microservices architectures with diverse endpoints pointing to various services. They also are effective for standard web applications. In contrast, NLB, they're preferred for high performance requirements such as TCP-based game servers or FTP servers due to its efficient handling of IP and port-based routing. So AWS auto-scaling groups, or ASGs, are essential for managing web applications that experience fluctuations in traffic. ASGs automate the process of adding or removing EC2 instances based on workload demands, ensuring optimal performance and resource utilization. With ASGs, we can define the maximum, minimum, and desired capacity of instances to scale out or in as needed. Additionally, ASGs seamlessly integrate with load balancers, automatically adding newly created instances to the load balancer pool and replacing any unhealthy instances for improved reliability and availability. Before we create our auto-scaling group with our load balancer, which has routes to our EC2 instances, let's go ahead and create a security group for our ALB. So I'm just going to call this John ALB test 1, and you can give it a description of whatever you want. And then we're going to add a inbound rule. So I'm going to create a HTTP inbound rule, which will be from port 80, because we want to allow it to be connected to from anywhere, we'll put the CIDR block for 000 for that. And then in the outbound rules, we can select custom TCP. And we know that our node application will be running on 3000. So we want to take traffic to our load balancer, or AWS will provide us a URL. And then that, when we go visit that URL, that will be the load balancer that AWS creates, this ALB. And we want to reroute our request to our EC2 instances and through port 3000, because node will be running on port 3000. So we can just go ahead and say this can be from anywhere, because any of our EC2 instances, they can be created or destroyed at any time. So we just want to connect to any of those EC2 instances from anywhere. And that's all we really need for our ALB security group. So if we click back to security groups here, we also want to create a security group for our EC2 instance. So once again, I'm just going to call this John EC2 test 1. Doesn't really matter what you call it. And this is just going to be for EC2. And we're going to need a inbound rule here. And it's going to need to be a custom TCP on the port 3000. And then what we do is we actually link to the previous security group we just created, so the ALB test. That way it will restrict the traffic that's coming through and being received on port 3000 from the ALB security group, and no other ports on 3000. So we can go ahead and we can just add that there. And what that means as well is, in the previous videos, we had this set to anywhere, which meant you could just go to the IP address, but we're restricting that because we don't want to be able to go to the IPv4 DNS or address of the EC2 instances themselves. We want to make sure we restrict that and go directly to the load balancer, which will handle that for us. So we'll keep our EC2 instances private, and then the load balancer will be publicly exposed. So we may want to connect to this through SSH to look at any individual EC2 instance. So we could put SSH in here, and we can make that accessible by anywhere. So that's all we really need is TCP 3000 and SSH. So, and if we have a look at the outbound, we can see that that's allowed for all traffic there. So we can go ahead and just create that security group. So now we have our ALB and EC2 security groups. Now what I'll do is I'll create a launch template, because what we're doing when we're creating an EC2 instance is that's going to be managed by AWS through these ASGs. So we just need to provide information to it, so each of the new EC2 instances can install Node on them and NestJS and compile and build our project and all of that sort of stuff. Create a launch template, and I'm just going to call this NestJS Simple API Test 1. You can call it whatever you want. You can have a template version description, or you don't have to have that. So simple NestJS template. And if you wanted, you put template tags or source tags. So we're just going to go to quick start, and I'm just going to choose Linux Ubuntu, and I'm just going to choose this free tier eligible AMI, which will just be on 64 bits here. And the instance type, I want to choose the T2 micro because that's the free tier eligible. The SSH key pair, I will just use the existing NestJS one, although network settings, we can choose, say, 2B, and then we can select an existing security group since we just created one. And I'm going to select the EC2 test security group. So recall that that will give us the connection through the load balancer to port 3000 and also the ability to SSH in there. And then we can just scroll down and we can go to advanced details here. And we can scroll down to user data. let's create our user data, which will be the script that runs when our EC2 instance is bootstrapped. So what we can do is we can just start off by having the hashbang/bin/bash command, because we'll be executing a bash script here. And then what we'll do is we'll just update our package repositories. So we can go apt-get and -y update. And then what we'll do is we'll run a apt-get -y install git, because we're going to need git to get the API from GitHub. So what we want to do now is we want to create a temporary shell script because for additional setup. So basically what we want to do here is we want to run cat, and then what we want to do is we want to create a temporary script. So we'll put that in the TMP folder, and then we'll just call it a subscript.shell. And then we'll have this here document delimiter, EOF. So what's happening here is firstly, and they'll be paired with another EOF. And what that means is if everything that we have, so say we just had an echo command here for setting up Node.js environment, what this will do is everything between the EOF, that will be put into this area in here. So basically we got this redirection operator here to redirect the output from the cat command into a temporary file here. And then we got this here document delimiter here, in which the subsequent EOF, it marks the text, or the text in between those that we marked and then put into the cat command. So we're doing this because it helps us to get around any permission issues or user related issues, because right now we're creating it as a user, as a root, but when we log in, we'll be logging in as Ubuntu, and then perhaps commands will be running through Ubuntu. So we don't want to lose any permissions because if you have permission issues, some of the scripts, the lines just won't run for you. So we're just avoiding that. So we'll just put our commands in there. So when you build a NestJS application, when you install Nest and Node on your computer, there's a bunch of environment variables set, but this new Linux, so it won't have access to those. So what we can do is we can actually just export those. So we can say the node environment equals production, and that's used when we actually build the project. So another thing we probably want to do, and I'll just put this on each line so there's enough space there, and actually I'll make this a little bigger so we can see this, all the commands here. So we've exported node env for production, so we can build our NestJS project, which we're going to get from GitHub in just a moment. But we can also export the path variable, and what we'll do is we'll just set this equal to a string here, and we're just going to say / whatever the path is, but then we want to put the node version that we're going to install in here. So this will make more sense when we write the next command, but just bear with me because we're going to need to install nvm to get specific versions of Node. So what we'll do is we'll just say, well, from the path, we know that there's a home directory. So we'll link it to the home directory onto the Ubuntu user. And then what we're going to do, we're going to install nvm. So there's going to be a .nvm file here, and you can access different versions through that directory of Node. And we specifically are going to install version 18.13.0. And that just happens to be what I have used on my computer. So I haven't updated to the latest version of 20 or whatever it is. And I just want to make sure that my NestJS version is, and NPM versions and all of that is in line with what's going to be used on this Linux server. So we have a path there, and then I added on that /bin to point towards the binary there. And then what we'll do is we'll actually want to install the node version manager. So we want to fetch the NVM shell script via HTTPS with the curl command. So we can just run curl, and that comes with Linux. And then we just want to have the -o- flag there. That indicates that the output will be displayed in the terminal rather than saved to a file. And then what I'm going to do is I'm just going to go to Google here, and I'm just going to type in raw GitHub user, because I looked at this before. And then I'm just going to copy this in, and I'm going to return to my template here. And basically this shell file is what I'm going to get, but I'm going to get it on my Linux server. So that's why I'm using the curl curl command. So if I just get the NVM version 0.39.7 and install that, that's all well and good. And then what we can do is we can actually just pipe that to bash, which will execute the shell script. So we're installing this shell script, we're loading it up into the terminal rather than saving it to a file, and then we're piping that output to the bash program, which will then actually go ahead and execute this installation script here. So then that's how we can get NVM on our new Linux instance. Now what we want to do is we want to set an environment variable for the NVM directory. So we can just go export NVM _dir equals the /home /ubuntu /.nvm. And with that NVM directory, what we want to do is, firstly, since we've just installed things, we first just want to have a check to see if the NVM shell file exists. We can actually go ahead and .source it. So let's just have a look here. So we can just run this command here, -s, and then put in /the NVM directory, and then it will just be whatever that is, which we've just specified above, /nvm.shell. And that should exist because we've used curl curl and we've installed it. And that's just a safety check there. And then, you know, if that evaluates to true, what we can do is we can just go ahead and we can just .source it. So we can just go ahead and we can just copy this here. So the .sourcing allows NVM functionality to be available in the current shell session. Now what I want to do is now we have NVM. I just want to run an NVM install version 18.13.0, and then we set the default NVM version to 18.13.0. And now that we have that node version installed, we can go ahead and we can install some global dependencies. So what we'll do is we'll just run an npm install -g, and then we'll get the npm version that I have on my computer, which is 9.3.0. And then I'll just go ahead and I'll just copy this down twice. Alternatively, you could just add it to the same command. But we're going to need the process manager. And then we're also going to need the NestCLI. And we need the NestCLI because we're going to use it, we're going to need it to be able to build the project on the server. So we can just get whatever version that is, 9.1.4, that's just what I have on my computer. And then one thing we may want to do, although this is optional, is we can just run an npm -clean -- force. We've just installed some node modules, and just to make sure everything's all well and good, we can just run that command if we wish. And then what I want to do is I want to get my GitHub profile here, and this will be linked in the description below. If I click on code here, I'll be able to get the Git file that I'll be able to copy. So what I'll have here is, since we've installed Git before, I can run a git clone, and then I can just go ahead and I can just paste in that command there. And then where I want to clone it to is into the home directory, into the Ubuntu user, and into a folder that I'm going to call NestJS API. So then we can go ahead and we can navigate to that directory here. And now that we're navigated into that NestJS API directory, we can go ahead and install the node modules. So we can run an npm install, and then we can also go ahead and we can run an npm run build. And if you don't have your environment variable set properly, this npm run build won't work, and then the rest of your scripts won't work after this. So what we can do is we can just say, well, now what we want to do is recall that we're making this script as a root user, but we want it to be accessible by the Ubuntu user. So we can just change the ownership permissions for that folder recursively, such that the owner and the group are both Ubuntu user. And then we can go ahead and we can just go ahead and point towards the NestJS API directory that our project will be cloned to. And then since we've built it, it'll be in the disk command. The disk folder. So now what we can do in addition to that is we could just change the permissions. I'm just going to change it to 755. So read, write, execute, read, execute for the home Ubuntu. And I probably should just copy this to this folder here. So now what we can do is we could just run pm2. We could go ahead and we can start main.js file, which is going to be in the disk folder there. And in addition to that, what we can do is we can run a pm2 save, and that's all we'll need to have there. And pm2 save, it saves the current pm2 process list for automatic restart. So now we've done that, something we could do in addition is I might just copy this command here. And what we could do is, now that we've created this temporary script, so we started that up here. Now that we have that written, we can go ahead and we could just change the ownership. And then we could also add to all the execute permission for that, just to make sure that we're able to execute that script as any particular user. And this is just a temporary script anyway. So what we can do now is we can actually execute the script as the Ubuntu user. So we can say the user that we want is the Ubuntu user. And then we'll go ahead and we'll point towards this file, which is in the temp subscript.shell. So that's where that is there. And that essentially, all of that is our user data there. So just to shorten that out a bit, we'll just check over everything and just recap. So we've got the hashbang bin bash. We update all of the Linux packages. We install Git. We create a subscript. Then we go ahead and we export some environment variables. So we're able to build things. We export this path here because this path is used to point towards the node binary. We go ahead and we install NVM. And we export an NVM directory. So we can .source that, and then we can go ahead and use NVM to install 18.13 as the default. We can just go ahead and install Nest PM2 and NPM. We do cache here. We go ahead and we clone the repo that we saw at the beginning of this video, and we clone it into this folder here. We cd into that folder, and then we can run npm install and npm run build. We just change the ownership and permissions, and then we can run pm2 to actually start the build.js file, and then we can run pm2 save, and then that will all be happening from within this subscript shell file. And then that actual subscript shell file, I just change the permissions on those just to make sure everything runs, and then we just run it as the Ubuntu user here. So what I'll do is I'll just go ahead and I'll create launch template here. I can view the launch templates, and you can see that I've got version 1, latest version. And if we make any errors or you need to make any changes, you can just right click this and modify template. They'll create a new version, and then you just need to go ahead and set the default version. You can actually delete the old version if you want. And that way you can have a history. So maybe previous scripts were working, but then you need to add more to it. So let's take a look at actually creating our load balancer and auto scaling group here. So we've created our security groups. We've got our launch template here. Let's go ahead and create our auto scaling group. So I'm just going to call this John NestJS ASG test 1. And now we can actually go ahead and get the NestJS template that we just created. So we can have a look at that. Here we've got it here as the template name here. So we can go ahead and we can just select that, and it just shows you some overview of those details there. We can see it has T2 micro for a free tier EC2 instance. And then we can choose the instance launch options. So this is just an overview, but you can override the launch template if you want. So what we can do is we can just choose this default VPC here, and then we can just choose all of the regions, and this just defines which availability zones and subnets our auto scaling group can use for this particular VPC. So now what we do is we go next, and then we actually want to attach a new load balancer because we haven't created our load balancer yet. And this is what's good about AWS, is the load balancer just magically works with this auto scaling group. So we can go ahead and we can just choose an application load balancer. We can give the load balancer a name, LB for load balancer, and we want it to be internet facing. And what that will do is AWS will give us a URL that anyone can connect to. And then we've restricted our EC2 instances, but we can see that we've got these availability zones. These are all pre-ticked for us. So we've got these listeners and routing, and then we're going to be listening on port 80, which is just the port for HTTP. So we'll just go ahead and we'll create a target group, and we'll just select this by default with default settings. Now we will need to change that. By default, I think it's going to fall to port 80, but we want it to port to 3000. So we'll come back to that. And then we can just choose the default for all this stuff. You could do health checks and enable metrics and all that, but this is just a test project, so we won't do that. So we can just go ahead and we can just click on next here. And this is where you specify the desired capacity. So I'm going to start off making sure that the desired capacity is 1, and it's very easy. We can just change that to 2 later on, and then we will do that so we can actually see that everything's working well and good. But just to start off, I'm just going to have the desired capacity as 1, the minimum EC2 instance to be 1, and the maximum to be 1. And then you can also attach the scaling policies. So how it actually scales, you might want to do it differently. Maybe you know that at certain times, you have to do some system tasks that are computationally expensive, or, you have a huge, maybe you want to do it based on input output request or whatever. I'm just not going to have any policies, but you could specify them in more detail there. And I'm just going to click on next here. Again, you could add SNS. So we're not going to do that. And we're just going to click on next here. And this is where we can just review everything, make sure everything's selected. So I'll just scroll down to the bottom here and create auto scaling group. So that's just going to take a little bit to load. So just before we created the target group and we chose the default target group, and that's actually not what we want, although we didn't really get an option in that other menu to specify what we did want. So we'll just go here and we'll create a target group that supports the instances, same as before. And this will be the EC2 target group new test. And we just want to support port 3000 here. So all the rest of the settings will be the same. And then we'll just go ahead and we'll click next here. And then we can go ahead and we can register the targets. So we see that we've got a target here. And we can go ahead and we can create the target group. So we've selected the new target group, which has port 3000 here. We click on the load balancer, which says none associated, and we associate it with an existing load balancer. That will take us to the load balancers menu. Then we can go ahead and we can click on that load balancer and we can go to actions, and then we can go to, actually let's click on the load balancer, and then we can go ahead and we can change this listener here. So if we go to edit listener, we can see that it's chosen this John NestJS ASG test LB, and that's what we set it to before. But that actually, the target group actually we want to send it to is EC2 TG new instance. So we actually want to make it go to port 3000. So let's go ahead and save those. And if we come back to our target groups here, we can see that the inverse has occurred. So we actually got the port 3000 going there. And if we come to instances, we can see that we got an instance running. However, if we click on the instance and we try to open the address, and note that it's running on port 3000. So if we try to go there, we can see that it doesn't actually work. It actually hangs, and that's because we've prevented traffic to the IP address from anywhere. We have to go there through the load balancer. So that means if we go and visit our load balancer, which we can get from here, we can see that it is actually giving us the IP, and we can see this IP address because if we go into instances here and we check out the particular instance that we're running, that actually is that IP address here. With that in mind, we can go back to our auto scaling groups. And if we click on our auto scaling group, if we look at this automatic scaling here, if we go to details and we go to group details and we edit these, we can set the desired capacity to 2, and that will change the max desired capacity to 2. And then we can go ahead and we can update that. Now that's been updated for us. If we click on instances here and we refresh here, we can see that it automatically creates a new instance for us. You can see that this one has 172.53. And if I continue to refresh this, you can see that it's changed to the other server. So we can see that the load balancer is working effectively. It's distributing our application load to the EC2 instances. And we got auto scaling. So we got the auto scaling groups that will be able to automatically provision the EC2 resources based on our specifications. So that's what I wanted to cover in this video. In the next video, I might take a look at Elastic Cache and perhaps how all these AWS services work together. So please subscribe to my YouTube channel. Thanks so much for watching, and I'll see you in the next video. Cheers.